Okay, so what you guys are doing for the end of your homework is conservation of momentum problems. So I want to show you exactly what that looks like. So these all work out exactly the same way. So what we have in this thing, let's read this problem and make a cartoon as we go. And it's really important that you guys draw these pictures and just make this as simple as you possibly can. So let's read this thing. We've got a 620 kilogram moose standing on some railroad tracks. And an oncoming locomotive. So let's start drawing the picture. You guys can marvel at my terrific drawing. So we've got a train with a cow catcher on the front, and we've got a moose standing on the tracks, like the antlers. Good. So the mass of the train, initially, call that MT, is 10,000 kilograms. And the mass of the moose is 620 kilograms. Okay, and the train is initially moving at 10 meters per second, so let's write that down. Vt equals 10 meters per second, and the moose is 0. Okay, so that's all our before. After our collision, we've got the moose sitting on the train. So here's our train. Smoke, cow catcher, and on top of the train we've got a moose. And so this is our after. And so our system now has a mass, train plus moose. That's going to be 10,620 kilograms. And we want to know what the train plus moose's velocity is. So if we think about the moose train system, no external impulse has acted on the moose train system. So whatever the momentum of the moose train system was before the collision, the momentum of the moose train system must be after the collision. So the momentum of the train plus the momentum of the moose before equals the momentum of the train plus moose afterwards. So that's the mass of the train times the velocity of the train, initial, plus the mass of the moose times velocity of the moose, initial, equals the mass of the train plus moose times the velocity of the train plus moose, final. Now we already know this is 0, so we can stop worrying about that. Now we can solve this thing. We say, okay, we've got mass of train times the speed of the train equals the mass of the train plus moose times the speed of the train plus moose. Now what we're looking for in this problem is the velocity of the train plus moose. So let's divide both sides by the mass of the train plus moose. It's going to cancel out over here. So I'm left with the speed of the train plus moose equals mass of the train times the speed of the train divided by the mass of the train plus moose, or 10,000 kilograms times 620 kilograms divided by 10,620 kilograms. And if you put that into your calculator, you find out that that is 9.42 meters per second. The kilograms cancel out and we're left with meters per second for our units. Now let's stop and see if that seems rational. 9.42 meters per second is a little less than the train was moving initially, which makes some sense. It ran into the moose. It should slow down. So that's how every one of these things is going to be solved. So just to quickly review how you're going to go about solving these problems, draw yourself a picture. Label clearly what is going on before the collision and what's going on after the collision. Ask the question, was there an impulse? If the answer is no, then the momentum didn't change. So whatever the momentum was before the collision, the momentum needs to be after the collision. And then you're just in algebra land. So good luck.